Hello fellow broken Sherman owners. Hopefully that's not too many of you. So I thought I'd do a video of a strip down of a Sherman Max. I'm narrating this over the top because when I recorded this video I was full on with COVID and was feeling a bit rough and having coughing fits and didn't really feel up to talking over the video at the time. So here we go with the strip down then. So first thing you can see is the trolley handle. There's 4 screws to remove. I'm speeding up bits of the video like this that are just a little bit dull. The video is long. I will try and put some hyperlinks in for the sections of it, but bear with. So when you get the trolley handle off, there is 2 thin rods inside. They locate into 2 small holes, which hopefully you can see there on the underside of that handle. So obviously when you put this back together again, you've got to get those rods into those small holes, and that's what is the mechanism for the push button on the top of the handle. So that's what releases the handle. So the reason I'm doing this is to take the handle off so that the top cover plate of the body will go over the top of the handle and clear it. So you can see now pushing those handles back down, and then we're onto this top cover plate, which reveals the motherboard inside. I say motherboard, more like motorboard actually, the control board. So there's 4 screws again that hold this in place. Now when I was doing this strip down and rebuild, I tended to screw this cover on and off quite a few times just so that it was secure, because you'll see when the lid comes off there's a ribbon cable. And that goes from that motor control board to the display board that's fitted to the inside of that lid. I didn't really want that display hanging by that ribbon cable, so any time that I wasn't doing anything within that control board, I would just pop the lid back on and put 1 or 2 screws in just to hold it in place. So there you go, there's the control board. We've got the 3 thick phase wires for the motor. We've got battery connections. There's two battery connections. Also of note here is there is a thinner wire, another white one, which goes onto a plug, and they are the hall sensor connectors or connector. So there's the second battery connector. So just a note here, I put a couple of dots on one of the plugs, both sides of it. As I've never stripped this wheel down before, I just wanted to make sure that everything goes back the same way. So those 2 connectors couldn't get mixed up. I know which one goes to which. Also really important though, take a photograph of the inside of that board before you strip it down. So this part here, as you can see, I've picked the lid back up and I've turned on the power, and you will get some possibly a very slight movement of the wheel, tiny, but you'll also get a bleep. The display will come on for a split second, and that I'll explain in a moment. That's to drain down the board. It will hold charge just on that board even when the battery is disconnected, and with 100 volt electronics you don't want to get zapped. So here I'm putting some insulation tape over the battery connectors because they are going to be left unplugged. I just don't want anything to slide down inside those connectors and cause a short of the battery pack. So I think it's good practice to just protect those battery connectors. Next job I did was I marked the 3 phase wires, just marked them 1, 2 and 3, but I had taken a picture before I did this, and it was quite a good thing I did, because amazingly that permanent marker, that black permanent marker that's really clear there, that vanished. By the time I put everything back together again, you could hardly see any of those black dots. So I ended up having to rely on the photo that I'd taken, and at the end of that white heat shrink sleeving you can actually just see the coloured wires from the 3 phase wires, so I was able to put them back in the correct order. So whatever you do, take a photo or mark the wires, so then there's never any confusion when you reassemble it. It all goes back in the same order. Okay, so disconnecting the 3 motor wires, They can be a little bit tight, those screws, but for good reason, because that's where all the current's travelling through those posts and onto those ring terminals. Next is disconnect the hall sensor connector. I'd already run a blade across this just to cut through the sort of silicone sealant that they use to hold those plugs in place. So try and do that first, just clear a bit of that silicone out of the way, or just cut through it very carefully before you pull that plug off. So that's all you need to disconnect. So 2 battery connectors, 3 phase wires from the motor, and the hall sensor plug. And then you can put the lid back on. So here I'm showing all of the screws that are on the side panel, and yeah, just indicating that the pedal's got to come off first as well. So flick to the next shot. Now the lid is, having what I said earlier, I've left the lid loose at that point. Should have really screwed that back on, but I'd probably do before I do anything else with it. So Allen key, there's a grub screw on either side of the pedal. They are Loctited, they've got thread lock on them, but they do come out easy. Interesting to know actually, lots of the fixings, screws on this wheel weren't all that tight from factory. The wheel's got about 200 miles on it, 250 maybe at most, so it hasn't done a lot of mileage, but lots of those screws were not all that tight. So I feel a bit more assured now that once it's back together again, everything has got a decent amount of thread lock on it, and everything is, you know, tight enough that it's not going to come loose. So, yep, grub screw out either side of that pedal, and then it's got a hinge sort of shaft that goes through the middle. So all you've got to do is just tap that out. So I'll just use a screwdriver and this nice silver shiny hammer that I've got, which also doubles up as a ratchet, fortunately. So just knock that hinge shaft straight through, and then once you've cleared the pedal hanger, that will just pop straight off. Nice and easy, really quick and easy job. So that's one side pedal off, ready to go. So the next stage after that would be to undo the side cover, which is what I'm doing now. If I stumble on this video, by the way, it's because it's probably a month ago that I recorded this, and I'm only just watching it back now and deciding to narrate over the top of it. So I can't actually remember some of the bits that I did. I've tried to speed up the bits that are dull and boring. You'd probably argue that I could have sped up a lot more of it, and I think I'd agree. But here we go. So side panels coming off, all nicely fitted, no problems with that at all. And we're revealing the right side 2 battery packs. So you can see there 2 battery packs. The top right, there's a fuse holder with a fuse in it, and we can see the motor wire going up from the centre up into that top panel. I'm just showing there we've got 3 bolts for the axle. There's then 6 bolts that hold the body onto the pedal hanger. We've skipped now, so we're going to take the other pedal off. I still haven't put the top cover plate back on. So this will be one of those situations where it's do what I say and not what I do. But I promise you, I did screw it back on. So the moment I was going to lift it off this stand, I'd have screwed it back on. I hope. Otherwise you can all laugh at me. So this second pedal coming off. So both pedals off, and we're ready for the second side panel to come off. So again, I've sped this up a little bit. So that side panel's coming off nicely now. So the reason I did this strip down is that I'd seen a forum post online that some of these Sherman Maxes may not have had quite enough sealant on them on the part where the motor cable enters into the motor. And I was a bit concerned by mine. It's quite low mileage, as I say, 2 to 250 miles on it. I wanted to strip it and check it because, you know, I want this thing to do thousands of miles. I don't want dirt, grit and crud to be getting inside the motor. So here we have the other side, again exactly the same bolts, 6 small ones, 3 big ones, and they are big. I think it's either 8 or 10 mil Allen key you need for that. Okay, so front and rear lights unplugged. That's ready for those roll bars to come off. Next here, okay, so we're back around the other side. I'm undoing 2 little screws. They are tiny, and they are a cable clamp that holds the motor cable in place, just holds them onto the body. Be careful that you don't lose those screws. Whatever you do when you're doing this sort of work, make sure you never do it in an utterly stupid place, like on wooden decking with gaps down the planks. Yeah, I mean, no one in their right mind would do that, I'm sure. But yeah, just a bit of sound advice there, because you know for a fact you'll lose one of those screws down the gap in the plank. Of course, I'm a professional, so that never happened to me more than twice. So there we have the cable disconnected. Hopefully, finally, I may fix the cover plate back on the top. So I'm just clearing out the wires out the way, make sure nothing can touch, make sure those battery connectors are still safe with tape over the top. I didn't show you something on video because I don't always recommend it, but after I press the power button on the top panel just to drain the electronics of the control board, I did want to check to see if it was actually dead. So what I did is a little trick that I've done before. I've stripped loads and loads of EUCs down in the past, and that was to get a pair of long nose pliers and just touch them onto the motor side of the battery connector, not the battery side, so the control board side of the motor connector, and I did get a spark. Okay, so there was still energy left in that board. As I say, don't necessarily recommend doing that. But what I would say is just be aware that even turning the power on and seemingly letting that board drain down, there's still energy in there. Okay, so just bear it in mind when you're poking your fingers in and around it, that if you've got a 100-volt wheel, you will feel that as a buzz. So there we go. I've finally screwed the top panel back on. So we're on to the next clip now. I honestly can't remember what's next. It's probably to start undoing the motor bolts. Oh look, blast from the past. Yeah, air wheels. I've stripped hundreds probably of air wheels down in the past, so I'm quite used to stripping EUCs down. But this is my first time stripping a veteran Sherman, so I was really taking my time with it, and I'd advise you to do the same thing. Don't rush with it. I've stripped it down again since, and it took me a fraction of the time the second time. No time at all. It was really quick. So next here I'm unscrewing 2 screws. Believe it or not, they're self-drilling screws, which I'm not a particular fan of in a manufactured product. Self-drilling screws generally, they're an installation product. I use them a lot at work, but I don't manufacture electronic components like this. So not brilliant, but they seem to do the job. They didn't strip the metal out, but be prepared. Don't over tighten them when you put them back in, because they will strip a thread. So there's 2 screws either side. That's once there's 2 side plates off, it's only those screws that are holding the roll bars in place. So it's quite straightforward to pull the front and rear roll bars off now, because there's literally nothing holding them in place. They're just slotted into those tubes at the bottom. So all I did is I just got a piece of wood and just tapped it at the bottom corner, and just tap each side in either direction just to move it slightly away. And you'll find just giving them a bit of a wiggle, bit of a tap, and probably flip the wheel over, tap it on the other side as well. You can see it start to move, and then you just wriggle them free, and you'll soon get the hang of it. Okay, so this is something to be aware of. Did you see then I pulled the wheel over, and the batteries came unstuck. So this is a really bad thing about this Sherman. Those battery packs, they're heavy. They are heavy, and they're stuck in with two tiny little foam pads, nowhere near enough to hold those batteries in place. So yeah, take a tip from me, stick them in place, get some gaffer tape, duct tape, stick them in place while you're working on it. Or if you're concerned about them, do what I did off the video. I didn't record that bit, but what I did is I pulled all 4 battery packs out and I sealed them in place properly. Used some a little bit of double-sided tape and some blobs of sealant as well, so that they're properly held in place and they're not going to move, and probably also offer them a bit of shock absorption as well. So yeah, the foam pads that come with it, hopeless. So there's the front roll bar removed, just the rear one to go. See, the wheel's a bit mucky. Most of my riding has been on road, but I did do about 30 miles of sort of track riding, which is a bit sort of gravelly and dirty, and that's where all the dirt's come from on this wheel. And it's what was made me concerned about what the state of the inside of this wheel was going to be. I was sort of hoping that I'd get it apart and I'd find that it was fully sealed up and all would be hunky-dory, but we'll see what happens. So just giving that rear roll bar a bit of a tap, and that should hopefully wiggle free. See, it's already nice and loose. Just giving a bit of persuasion. It's quite difficult doing things on these wheels when you hold them in this position, because they just want to rotate all the time. There's nothing to hold them in place. So you just take your time with it. Once you've taken one of these wheels apart once, trust me, the second time is a doddle. It's so easy. So that's almost off. There we go. So that's the rear roll bar removed. They're just as easy to refit. It's not a problem at all to refit those bars. So it's really quite straightforward. Of course, now you've lost your lifting handles, so you've got to lift the wheel up from the plastic body. So the next stage, I believe, will be going on to the small Allen bolts. So 6 either side. And they hold the 2 sides of the plastic body in place, and they bolt into the pedal hangers. They've all got thread lock on, so in that respect, the build quality is good. As I say, they weren't particularly tight, some of them, so they certainly weren't torqued to any spec. They would have just been done by hand, probably, maybe by gun, but they're quite variable in how tight they were. I must admit, I didn't use a tool wrench putting it back together again. I used I won't swear, but yeah, fairly tight for everything, but not overly tight, knowing that some of these bolts could strip. So here we came across a little sticking point, and possibly a sticking point if you're out on the road trying to strip a wheel down and maybe do a puncture repair. The 6 bolts, 3 on either side that you can see there, the big ones, they were tight, and I mean tight. So I couldn't get them off with a ratchet. I stopped the camera, I went off searching for a breaker bar that I've got. I couldn't find it in the garage, so I had to settle with a compromise, which we'll see in a moment. But yeah, thankfully, they were tight, and they need to be tight. That's the main part, holding the wheel to the body. Okay, so what I did, I decided to give up on those 3 bolts, and I went back to the other side, undo the 6 smaller bolts, so that we're getting ready. But the next stage is going to be those 6 large bolts, so we'll come to those in a moment. If you hear me pausing, it's because I'm drinking. As I say, I'm probably about a month the other side of COVID now, but I'm still affected by it. Okay, you might guess what's coming next if you can see the silver piece just the other side of the wheel. Bit of scaffold tube. That'll do the job. So same ratchet on, Thankfully it's a good quality ratchet stroke hammer, obviously. Here we go, and away we go, nice and easy. With that amount of leverage, there's no resisting. A couple of them did make a nice cracking noise as they released, and again all those bolts had thread lock on them, and I put new thread lock on them when I rebuilt the wheel. So again, nothing rushed on this strip down, because I wanted to learn about the insides of this wheel. You know, being the first strip down, you want to see exactly how it's built, and also study it as you're taking it apart, so that you can work out the best order to strip it down. Certain things, you know, it doesn't really matter, but in other respects, you know, it will make it a lot easier if you take the right bits off at the right time. So I wasn't fully taking those bolts out at this point, so it was just a case of loosening them so that they still held in place, and then loosen the 3 on the other side, and then I'll be able to lay it down and properly take the bolts out. Excuse me. So just fully loosening those bolts, took one out to have a look, and you can see they are quite beefy. Tiny little bit of thread lock on that one, but you know, it held tight, so it did the job. I really could have speeded this video up a bit more, couldn't I? If you've fallen asleep, comment down below and let me know. Okay, skipped to the next bit. Okay, so the wheel's on its side now. I can properly take the bolts out. Once release both sides, the wheel will be floppy and loose, and it will be ready to come out. So that should be the next stage after this. Will be actually wheel removal. Again, it's not too bad to do. I found it best to do with the wheel laid on its side. I was able to grab the body, and you do need to flex the body apart slightly so that that cable will pass through the body. Now I don't know whether you saw there was some silicone on that cable, so it does look on first glance that it's properly sealed, but you might see it's different soon. Now with the weight of those batteries, that case is now a little bit wobbly, so I did put something in there just to prop it up. Well, you can see it there, look, a can of Heinz tomato soup. Don't ask me why, it was there and it worked. So that basically just took the weight of those top 2 batteries, stopped it flexing the body. Whatever you do, don't use mushroom soup, it has to be tomato. Okay. So what I'm doing now is I'm cutting away the silicone that's there so I can remove the pedal hanger. There we go. That was sped up. That did take a little while. You've got to be really careful, especially if you're cutting with a knife. Make sure you don't cut through the cable. There we go. Look how much silicone's there. Oh look, 0. That's a problem. That's a problem that Veteran or Leaper Kim need to fix immediately. That is no good. That is no good at all. For a 200-mile wheel, you would not believe how much crap, crud, dirt and mess was inside of this motor under those covers. Now the black covers that you can see that I'm about to start removing, they're all sealed. They have a thin layer of silicone sealant on them, which is a brilliant job. It's exactly how they should be, all nice and sealed around the outside of the rim, and then they completely leave the cable entry unsealed. It's shocking. I really don't understand it, why they'd make such a massive cock up. If you do own a Sherman Max, I would invest some time, get to this point at least, and just check your motor, see if it's sealed or not. If it isn't, you need to go further. You've got to strip it and clean it and then seal it, just purely based on the amount of dirt and rubbish that I found on the inside of these covers. Yeah, it was quite bad. And you know, imagine after a few thousand miles, or you know, some rides in the wet, You know, it's going to be a state in there unless you seal it properly. Anyway, so here I'm just starting to break that seal on the cover plate, just using a really thin screwdriver. What you might find easier is if you've got like a scraper, but a fairly stiff one. That works well to break that sealant as well. But you can see that it's starting to move. There's really quite a tight tolerance on the inside of that plate. So don't go levering up one side only. You've got to do it as equally as possible and try and bring up that plate as square as possible. Otherwise you're just going to get it stuck on that centre axle. Hopefully that I'm explaining it in the right way, but yeah, lever either side of it so you bring it up square. Eventually, once you get it a certain way, you can start to get your fingers underneath it, and then you can just wobble it backwards and forwards until it frees up. So I think once I'd known that I'd cleared that silicone on that side, I thought I'd loosen up the other side as well. Give it a good clean up first. Always good practice, because I mean the whole reason we're stripping this down is because of dirt. So there's no point introducing new dirt to the inside of the motor. So I did give it a full wipe down and clean off all the way around on both sides of the motor before I expose the innards of it. So I'm keeping a little pot to one side, and all of the screws are going into that pot. And just a bit of reassurance, I found I could just chuck them all in a pot because it was really clear what goes where. You're not in a position where you've got 6 different lengths of the same type of screw and you've got no idea which one goes in which hole. It's all fairly straightforward and obvious. If you are concerned, you can lay them out in an order if you like on the floor, or you could put them in bags and mark them. So there's various ways of sort of noting which fixing goes in where, but I didn't find I needed to with this. It was all pretty obvious. Okay, so that's all of the screws removed from the non-cable side of the motor. I think I ended up actually removing that side first just to have a look at it. So look, I found a proper hammer, or rubber mallet this time. So each time that screwdriver is going in, I tend to move it onto a different part of the wheel just to try and keep it square as it comes up. Once it started to lift, I might give that screwdriver just a slight tweak. But you've got to be careful you don't start to damage the rim because it is quite soft. So it doesn't take much to damage it. So just levering it bit by bit, and then once you can get your fingers underneath it, you will find it will lift up. Really could have sped this part of the video up, really, couldn't I? This is the most detailed part of the video, is removing a lid. If you're really dull, you could always play this in slow motion. Here we go. So yeah, managed to get my fingers underneath, just giving it a little rock side to side, and off it comes. So there's the non-motor or non-motor wire side of the wheel. So I'm just looking now at the inside state of it. This side I think was reasonably okay. There was little bits and pieces on the inner face of the bearing, but it was reasonably clean. It wasn't too bad. But I could see on that side of the motor, the black, yeah, I could see dust and bits of dirt on there. Yeah, it didn't look too bad. I thought, oh, maybe I've got away with it and it just needs a bit of a wipe. All looks okay. But then I'll remove the motor and you'll see what's really inside it. For some reason, I think I forgot. Yeah, I forgot to press record on removing that motor. I'll explain in a moment how I did it. But look at this. All that inside the motor, plus more that I scraped off. And that stuff, it's all going to start getting in the bearings. It's going to start wearing away at the magnets, wearing away at the motor coils. It's really not good to have that inside of a electric motor. Everything's just going to start to get abrasive. So anyway, yeah, removing that part of the motor, it's quite simple. All I did is I got a piece of wood on the ground, and the side that you can see at the moment, the side that hasn't got the cable going into it, place that onto the piece of wood, and then stand above it. I put a hand on each side of the tyre, and then just really swiftly push the tyre down to the ground, and the motor will just pop out. And again, if you've done it once, it's dead easy to do. Putting the motor back in, slightly more exciting, but you'll see that coming up, because I think I did actually remember to record that part. So the little blue circuit board you can see there, they are the Hall effect sensors. So basically what they are is they're electronic switches that work by magnets, and they help to tell the control board what state the motor is in. So they will alternately switch on and off. So if you imagine, they're a binary switch, so they can be 1 or 0, or true and false, or open and close, whichever way you want to think about it. And they will alternately switch on and off. And all the magnets around the motor, around the rim, they're all reversed. So you've got a north pole, a south pole, a north pole, a south pole, and that's what turns those little Hall sensors on and off, or switches them, open and close them. And that's how the motor knows how to control the motor. It's able to sense really minute amounts of rotation. Funny enough, I've made a video about testing Hall sensors. I've already got that up on YouTube. It shows you my process of manually testing them. I did build an electronic tester for them using LEDs, so I could watch the LEDs come on and off and test all the Hall sensors. But I couldn't find it, so I did the manual method, and I thought it'd be a better way of showing it actually as well. So the reason I made that video, of course, is because I damaged the Hall sensors on this build, on this Stripdown. So what I'm showing here, you saw there, I pointed to the sticker on the tyre. That was what I used partly to note which way round the motor was going to go, because it is handed, it does need to go back in the correct way. You'll also see I showed there that the magnets are not central on the rim. There's a slight gap on one side and less of a gap on the other. So do make a note of which side the cable is on that motor. On my wheel, and I'm assuming it's probably standard on their builds, but the cable went in on the side that the red Kenda label was on the tyre. But looking at the build quality of these with the sealants, I wouldn't bank on that. So just note it down first. So I think we're about to do the exciting part now and stick the motor back in. Oh no, we're going to seal it first, of course. Yeah, so I've got some non-acidic silicone sealer, or sometimes referred to as a neutral sealer. I just chose a black one. I chose a good quality one, good brand. And all I'm going to do is, firstly on the reassembly, after I've cleaned everything out, I gave it a really, really good clean, and also cleaned off the old sealant as well. I'm going to give it the thinnest smear of sealant I can, and also then just spread it out with my finger so that it's 100% coverage on the side of that rim, so that I know once I pop the motor back in place, it's 100% sealed all the way around that rim. Hopefully I speed this part up because it's not the most interesting. It is, however, the most messy part of the job. So here we go. Really tiny bead. So I did this on both sides of the motor. And of course, unfortunately for me, I did it twice, because when I damaged the Hall sensor, only one of them, it was a complete motor strip down again. To give you an idea, how long would I have spent on the first one? Maybe between 1 and 2 hours on the first strip down, just being really methodical, really careful, The second strip down, I would say, got back down to this point in 10 to 15 minutes. It was that quick. Really quite simple the second time. One thing, if nothing else, I'm now completely comfortable stripping this wheel down, which is where I wanted to be anyway. So, okay, I may moan about the build quality, but I was always planning on stripping this wheel down. This just gave me a slightly earlier reason. Okay, here we go, the exciting part. So, I'm very carefully holding the motor and keeping my hands out of the way, keeping my feet secure in the rim, and just going to pop. Down we go. Lower it down as carefully as you can, but accept it will get to a point where you are not going to stop that motor from engaging and popping back into the rim. You just got to align it as carefully as you can so that it scrapes as little as possible when it pops back in. It was really quite a non-event on this because I was able to really get the rim held down by standing on top of it, keeping it nice and secure. It's raised off the ground as well so that the other side of the motor is not going to hit the floor. And then just really slowly lower it down, eyeing it on either side, try and get it lined up with the rim, and then just allow it to pull in when it gets to that point where the magnets take over. So here we're doing the wire side. I've popped the pedal hanger back on, and I'm now putting the bolts back into that cover plate. Don't over tighten these bolts, the small ones I'm talking about here, not the large ones. Firstly, they've got thread lock on them. Secondly, that cover plate has got a sealant on it that's going to help bond it back down. So there's no need to over tighten them, because you will strip the threads in the motor really easily. It's just an aluminium casting of a rim. It takes very little effort to strip the threads out. So yeah, don't over tighten them. I tend to, what I'm doing here, you'll see I'm holding the ratchet sort of right close to the head of it so that I can't get a huge amount of leverage on it, and I'll just nip each one up. I'll do it finger tight first, and then just as I would do on a wheel of a car, if I was undoing the bolts of a car wheel, I'm going to tighten them up alternately. So I tighten one up and then go to the one opposite. Once I've done that, the one next to it, and then the one opposite that, and so on in a pattern, so that basically we tighten this plate down as squarely as possible, because it is quite a tight tolerance onto the axle. So once that's done, I'm not even sure what I'm going to do next now. We're going to do the other side. Okay. This pains me to watch this, knowing that it was all a waste of time and I was going to have to strip it back down again. Not so much of the building, but the amount of time I spent cleaning it, getting all the silicone off. So anyway, here, this time I spread the silicone on the cover plate. Don't think it particularly matters which way you do it. Put it onto the rim or put it onto the cover plate. Doesn't really matter, I don't think. Doing it on this side though, where you're not having to sort of pop the motor back in place, it does allow you to align up the holes on the plate to the holes on the actual rim. That saves you quite a lot of effort trying to rotate the plates if they're not in line. So yeah, do take the time to do that. And then I'm just using a rubber mallet just to tap it down really gently and let it go down bit by bit, as square as possible. You'll feel it once the plate gets down onto the rim, because the sound changes, everything feels just more solid. And before I put any pressure on it, just rotate it so they can see the holes in the cover plate straight into the rim, and then sort of fairly quickly get a bolt in to make sure it's lined up. So a bit of thread lock on again. Probably went through about a gallon of thread lock having to do this twice. So again, what I'm doing, just tightening them up finger tight first, just so that I'm not over tightening one side of that cover plate while the other side's loose. Also, another good thing to have is that blue roll of tissue paper, because the silicone, well, when I'm doing things, silicone goes everywhere. So it's always good just to keep things clean. So you don't need many tools for this job. Mainly Allen keys, a Posse or Phillips screwdriver, a 10-foot long scaffold pole to get those bolts undone, and anything that will work as a hammer, which, as we know, is anything. Okay, so now we get to the part, which is sealing up. If you've got a brand new wheel and you're stripping it down to check this, and you see it in that state, obviously you don't need to go any further. You can just seal it straight up, seal that hole up where the motor wire runs into the motor, and you don't need to take the motor apart at all. So this would be your sort of starting point of the build, or the rebuild, should I say. So I'm shoving the nozzle down, getting some silicone down. I'm not putting loads in because I know very well it's just going to all squirt straight inside the motor, which is not what I want. All I want to do is seal up the hole as best I can where the wire comes out of the motor. And although you won't see it on the video here, but once this is sealed, I get the pedal hanger back in place, get the cable bent roughly to the position where it's going to be when it's fitted back to the motor, and then I leave the thing alone. And I left it at least overnight just to let it cure properly, so that I'm not constantly moving it around, because you will just break the seal, you'll create a crack or a gap, and then you'll have wasted your time. So if you're going to do this job, try and plan to take a couple of days to do it. So you do your strip down, do the cleaning, do the siliconing, get the motor cable in as close to the position it's going to be, and then just leave it alone and let it cure. So there I'm just cleaning up the excess around the bearing, because again, don't want to put silicone on bits that are going to be moving. So just taking my time, seal it up properly, and what I'll do is I'll get the pedal hanger back in place in a moment. So once I'm happy that I can't really see any gaps, I'm fairly confident that it's going to be sealed. There's always a little bit of a risk here, because I'm having to move the wire backwards and forwards a little bit to get this pedal hanger in, but I'm just trying to be as careful as I can. So all we've got to do is line up those 3 bolt holes, and what I do is just place them in, probably just 1 or 2, I can't remember, to be honest, how many I put in, but that just keeps that pedal hanger in the right place and allows that cable to sit where it's going to be, which, to be honest with it wants to sit in the right position, because that's where it's been. It's holding its natural position. So then I'm putting the silicone over that side of the cable as well, so it's sealing up the pedal hanger. That's the part you can see when you strip the wheel off to begin with. So if you do take the cover plate off, see some silicone there and think, oh, it's sealed, well, bear in mind you're only looking at that part of it, which is the outside of the pedal hanger, not the part that's getting all the splashes, the dirt, the dust thrown at it, which is the inside. So do take the time, get that motor out and check it out properly. So this is another part of the video that really I could have sped up. I do apologise if you're sat watching this, listening to me drone on. But at least, I'm sat here drinking a beer, enjoying myself. Maybe. So you can see silicone everywhere, all over my hands. I think I went through about 17 miles of blue tissue paper, cleaning everything up. There we go, all nice and sealed. Leave the bolts in and then leave it alone, let it dry. So this is another day. That's all now nicely cured, and we're ready for assembly, reassembly. So first things first, got to put the other pedal hanger back on. before it goes back into the body. So that just sits in place. I've not bolted it at this stage because you can't get it into the body with the bolts in place. So all the bolts removed from the axle. I'm going to tip the body on its side. The tomato soup is now gone, and if you're wondering, yes, it was lovely, and a nice bit of bread and some cheese with it. Actually, cheese goes really well with tomato soup. As I say, don't ever use mushroom soup for this job. It's just not good enough. It won't do the job properly. So yeah, cable goes into the body first, and then it's just a case of just slowly inching the wheel further up, or pulling the body of the wheel back over the wheel. Get the cables through the cable hole. I did find that the pedal hanger on the underside fell off once or twice, so I had to sort of relocate it as I was pushing it in. But you see the slot that the pedal hanger goes in, and just as when you're disassembling, you do need to sort of grab the body and just tweak it open slightly so that you can make enough space for the cable to get through. I think this is where the pedal hanger fell off. You can hear it; it just pops off the axle, so you've just got to reach underneath, get it back on again. Once you get it in place, you will find it will pop back on, and then just tweak it over. Each time I'm inching it forwards, I'm just pulling on the cable, make sure it comes up through that hole nice and securely without twisting. And then you'll see there it went in nice and easily. Probably trapped my fingers. Some of the plastics are quite sharp on this, so you do have to be careful moving this backwards and forwards. I think the pedal hanger may have came off again. Yeah, it did. So just reattaching that pedal hanger again. There's maybe an easy way of doing this. If you've done this job with the Sherman a few times, and there is an easier way of just putting the wheel back in the case, please do comment below, because it will help everyone. I'm sure the next time I take this apart, I'll probably find a slightly different way of doing it. But there we go. That's pretty much the wheel back in place. You should find all the holes should line up. So what I'll do next is either the 3 axle bolts or the 6 smaller bolts that hold the body in place. I can't honestly remember which. Oh, there we go. Big ones first. So again, plenty of thread lock on these because they are big bolts and they will take a decent amount of thread lock. This video was shot, was it August? I think it was August, but during an absolutely mad heat wave in the UK. It was roasting hot, so I was outside absolutely sweating. It was, I think it was 38 degrees, which I know for some people in the world, I mean, that's probably normal. But for the UK, that is not normal. That is hot. It's a horrible kind of heat as well. So I was really sweating, didn't feel very well, was just starting to get over COVID. But I was off work, and it gave me a chance to do this job. I think it was only a day or two after I found out online that this potential problem had been discovered. I checked the serial number on my motor, and it appeared to be possibly of the batch that was affected. So I thought, I've got no choice. I've got to strip the motor down and at least have a look. And yeah, unfortunately, it was completely unsealed. So there's the 6 small bolts gone in on one side. Again, I do them all hand tight first, and then tighten them up afterwards. What I probably will do with these larger bolts, after I've done another 50 or 100 miles, I'll probably just pop the sides off and just recheck them, just make sure nothing's come in loose. But as yet, I haven't actually done that because I've not had much chance to get back out and ride again. So now we're going to do the other side. As you can see, the top cover is still in place. Just stops everything falling apart and dangling loose. So again, we've got 6 bolts going in this side. You may notice if you spin the wheel at this point, you're probably going to find it's going to rub. That's just because it's not quite being held in the correct place. There's quite tight tolerances on the wheel passing through the body. So, but yeah, just trust it. Once you get all the bolts done up, it should bring it all into the right position, and everything should spin freely. So here's those other 6 bolts getting done up. I would imagine I'll probably put the axle bolts in on this side now as well. There we go. So there's the 3 large ones. Plenty of thread lock going onto those, and do them straight up as well. So thread lock on, get them in, get them tightened up so that the thread lock can cure and stick in that position. Again, I'll do them as tight as I can at that point, but I tighten them up fully with the wheel stood up, where I can actually, get some proper leverage on it. I think is that the 3 bolts on both sides now? Maybe I'll skip that part. Probably a good thing. Okay, so going back onto a stand just makes it a little bit easier to work on. So I think now what I'm going to do is probably take that lid back off again and start routing the cabling. Yep, that's right, so that lid is coming off again. It's quite nice when you get to this point because you know you're not far away. You've done all the potentially tricky, difficult bits, unless of course you've damaged a hall sensor, in which case you're going to be doing it again. So just to note, I fed the cable up here, but I didn't feed it back underneath the link cables between the 2 batteries. So I have actually taken that back off and rerouted it back underneath again. Don't think it matters too much, but it was underneath that link cable to begin with, so I've put it back in the same place. So ignore the fact that I'm routing it over the top here. It has got a sleeving over it, and there's sleeving also on the motor wires as well. So I don't think there's any problem if it goes back on top. But yeah, I did correct that. So yeah, motor wires back in place, and then I'm probably going to put the saddle back on that holds that motor cable in place. It's a bit fiddly to do with the 2 screws because they're very small screws, and they're also screwing into plastic. It's not ideal. It would be much better if they were a metal machine screw socket. But it is what it is. Just don't over tighten them because you'll strip that plastic really easily. And it is, it's doing a reasonable job of holding that cable in position. Okay, so that's the cable back in place. I think it's time to connect the motor up. I can't remember whether you'll see how much those black dots of permanent marker pen have disappeared. Hopefully you'll see in a moment. I was quite surprised. It must be the material. It's a heat resistant sleeving that goes over the top of the wires. It must just absorb the ink. But yeah, the dots had almost completely vanished. Luckily at the end of the at the end of that heat resistant sleeving, the wires are coloured, so you can tell where they're going. This is probably me looking at them thinking, where's the dots gone? Luckily I'd taken a photo. And also the cables do have a sort of natural tendency to want to go back in the direction that they were originally in. So, worst case scenario, you could just guess at it, test the motor. Usually the behaviours just a little bit weird, and you'll just need to swap 2 phase wires around and it'll probably correct it. So it's not the end of the world, but it's always better if you can get it first go. So each of those phase wires has got a plastic shroud over it. I was quite careful to try and slide those out of the way without damaging them, because I thought it was going to be awkward to try and protect those screws and the studs of the connections, you know, without using what was there originally. So I was quite careful to just try and get them slid out the way. Next thing then, after the phase wires, is going to be connecting the hall sensor connector back in. So that just simply plugs in. It can only go one way round. It's keyed, and I do again put some silicone over that. Here we go. So that will just seal up and hold that connector in place, and basically stops it popping out just from vibration. So we're nearly an hour into this video now. Lucky you. If you do suffer from insomnia, you know, feel free to use this, because I guarantee it will cure you. You'll be asleep in no time. So, are we going to connect the battery up? If you've never done one of these as well, obviously I mentioned that those boards hold some energy when you disconnect them. So bear in mind that when you plug the battery back in, that energy is going to rush back into the board again, so you will get a pop and you will get a bit of an arcing. But obviously I'm not connecting the battery just yet. There we go, I did what I said. Screwed the top plate back in place so that it's not flopping around. Okay, so yeah, we're going to roll bars next. I quickly figured out, I think, that just wasn't going to happen while it was on a stand. So I ended up having to sort of do it just on the floor. It was actually, I think, before I started doing this strip down, it was the roll bars I was thinking were going to be possibly the hardest part of the strip down and the rebuild, but actually they weren't. They were really quite straightforward. You just got to try and align both sides at the same time. So just sort of holding your fingers onto both sides of that roll bar where they slot into the holes in the pedal hangers. Align them both up at the same time and give it a wiggle, and it's really quite straightforward. So it probably took me slightly longer the first time. It took me almost no time at all the second time I did the strip down and rebuild. So there we go. They're in place. They're not fully seated, but I can give them a tap to get them in place. Oh no, that one's fell out again. I spoke too soon. I have no idea what I'm doing now. Perhaps I was going to get a bigger hammer. I was right. There's the bigger hammer. Oh, I know what I was doing. Okay, just lifting it off the ground slightly, just so that I could get easier access to both sides of it. Yeah, wasn't that sensible? There we go. So just tapping it into place. Do it really gently, because obviously you've got to align the holes on the pedal hanger and the bars. The screws will do some of the job of locating it, but you might as well get them as close as possible. And then get those little black self-drilling screws and just screw them in place. Just nip them up, don't over tighten them. No point in any thread lock either, that won't do the job. But as I say, they should do. Worst case scenario, if you end up putting these screws back in and you strip the thread, I mean, there's probably a couple of things you could do. You could maybe get like a piece of wood that's just slightly smaller than the inside diameter of the tube, and then just put a conventional screw into the wood. That would hold it in place. Or you're looking at, possibly trying to get some sort of nut in there. But either way, go carefully. It shouldn't have any problems. So again, just aligning up the second side, and then get those screws in place. All of this was filmed, by the way, on Insta360. So I've just placed it on its tripod. Really quite a good camera for this sort of thing, because you can just leave it there, not particularly worry too much about where it's facing, because you've got all of the directions. So just nipping those up, but being careful not to over tighten. Okay, next job, the exciting part, I think. That's putting the side covers on. Oh, I think that was the wrong side, that's why I walked off. There we go, got the correct side for it. This part, I really like the build quality. So these side panels, everything fits really well. They're machine screws that go into a metal threaded socket. So yeah, this part really impressed with, really good. I mean, overall, I think, you know, the wheel is great. The build quality is really good. I used to repair a lot of air wheels professionally. We used to offer a repair service. Those things, you know, they were nothing like the modern wheels. They were full of hot glue. You know, everything was fixed down with a hot glue gun. It was terrible, shocking quality, really. Even though they were really reliable wheels, they were brilliant. We got very few faults with them. You know, but they weren't designed like these modern wheels. These are much better build quality. It's just the odd bit that they get let down on. You know, if it wasn't for this lack of sealant on this wheel, I really couldn't say much wrong about it at all. I'm hoping I've sped this part up, but maybe I haven't. So there's quite a number of screws in here, and again, what I do is go around, just very lightly nip them up, and then go around a second time to tighten them properly. You could do this with a driver if you wanted, but I'm honestly not keen. If I'm not in a rush, you know, I've got the time, I'd rather do it by hand and feel how tight I'm doing them, because it's so easy to over tighten things with a driver. You can set a torque setting on some of them, but yeah, I just prefer to do it by hand. It doesn't take much time at all. As you can see, this is real time, and it's only taken a few seconds per screw. So how are we doing? We're an hour and 3 minutes into this video, I think, or roughly that. It obviously took way longer than that in real time. But then I wasn't rushing. You know, this is about learning the insides of this motor as well. So second plate to go on. Just giving it one last check that everything's okay. Again, it just all fits together really well. Really nice fitment. And then just nip up all the screws. You see the gaffer tape there on the floor. Always useful to have a bit of that lying around. I think that's what I used. I used it on the batteries. So when that first set of batteries fell out while turning the wheel over, I decided to gaffer tape them in place while I was working on the wheel, so that I knew they weren't going to anything was going to fall out again. And then when I was ready, I actually removed the batteries and stuck them in place properly. So I know now when I take the side panels off the next time, I know the batteries are not going to fall out on me. There is a really thin wire from each battery as well, which I'm assuming is maybe a communication wire or something from the BMS. It wouldn't take much to either rip that out of the board or even snap the wire. So I was actually quite fortunate that nothing went really wrong with that battery pack as it fell out. But all seemed to be good. So we're actually sort of quite close to the finish of this now. I hope it's been useful. I know it's a long video. You know, I'm sure that most people won't watch all of the video. But I'm hoping, you know, if you're doing a repair, or maybe not for this reason, maybe you're doing a puncture repair or something like that. Hopefully you can, if you get stuck, you can just skip to a part of a video, and it will just give you a little bit of sort of foresight on what's to be done to get it to bits. Once you've taken it to bits, it should be pretty obvious to put it back together again. You're just pretty much doing the reverse job. Another thing to note, obviously I've got the roll bars back in place. Plug the front and rear lights in before you connect the batteries up, and definitely before you turn it on, because I have heard reports of things going pop when people have plugged or unplugged them while the wheel's been turned on. And I'm honestly not surprised, because they're using a TRS jack connector, which, to carry power, it's not what they're designed for. And they will short out as you plug and unplug them. You can get versions of TRS jacks that don't short when you plug them in and out, but these quite likely aren't that type. So you potentially will blow something on the motorboard if you plug and unplug those lights while it's turned on. Yeah, they should have been a proper DC power connector, not a TRS. The TRS connectors and jacks tend to be what you use for things like audio signals, data signals. Sometimes they're used for RS-232 serial connections. Yeah, they shouldn't really be used for carrying reasonably high power 12 volt power connections. Yeah, that's bad design. So where are we at? I think we might be battery connection time. Here we go. So yeah, tape coming off, and when you do connect this battery, it will make a pop. Don't let it make you jump. It's just a bit of inrush current where probably those capacitors are charging up for the first time. Possibly the MOSFETs on the other side of the board. So it will go pop when you first connect it. Don't worry about that. Only worry if it goes pop, bang, smoke, flame, burn the house down. If it does that, worry. Anything else is fine. So both batteries connected. Going to poke that one back down out of the way. And then pretty much next it will be a case of testing. So lid back on again. And oh yeah, pedals. Forgot about the pedals. Unless you're really good at seated riding, you're going to need these. So again, this is pretty much just reverse job. You notice I'm wearing trousers now. This video skipped. I did have to. It did sort of jump around a little bit. So this is actually refitting the pedals after I'd stripped it a second time and replaced a hall sensor. So I did damage a hall sensor, and I did have to break it out, find a new one online, order it in, and resolder in a new hall sensor. Which, yeah, it's not a massive job. I've done it before, but it could be a bit daunting if you're new to this kind of thing. So there we go. I've got a new type of hammer now. It's a one that's grown from a tree. Does the job though. Just checking that shaft is sort of roughly halfway, and then I'm going to put the grub screws back in again. Thread lock them, because last thing you want is your pedal to fall off while you're riding. So we should be coming close to the end of the video now. I hope so, because I'm tired. I'm sure you are too. So get the correct Allen key. Again, I'm going to do both sides of the of those bolts up before I tighten them. So just get them in place first. Oh look, another part of the video that could have been sped up. It's just that I'm actually so lazy I didn't even watch the whole of the video back. It's so long. So long. Yeah, I could have sped this up. Anyway, stick with it. We're nearly there now. You've made it all the way through. If you have watched this far, well, I'm not sure I've got any respect for you. There must be better things for you to do. Okay, so that pedal's done. I'm hoping I don't show you the next side. Please skip the next side. Don't show the next side, come on. Okay, let's watch the next side, shall we? Yeah. So unsurprisingly, this is exactly the same as the first side, except I've got a bigger hammer. So feel free to skip forwards a few seconds if you really want to. So more thread lock. One of the reasons for doing this strip down as well, I know this, this sort of incident with the sealant made it happen probably sooner than I'd planned, but I was always planning on stripping down the wheel, and part of the reason for that was so that I could come up with what I will need as a toolkit to carry with me in case this has to be done at the side of the road, because this is a long range wheel. It is capable comfortably of 100 miles. I had 120 miles out of this on its first charge, riding it fairly sensibly, but it can do that distance. It really can. So I could find myself in the middle of nowhere at the side of the road, maybe with a puncture, probably the most likely thing that's going to happen. And most of this video is relevant to fixing a puncture. That wheel's got to come all the way out. So I wanted to come up with what's going to be a competent toolkit, because you get these sort of little multi-tool things that quite often cyclists use. I don't necessarily think it's up to the job, to be honest. I did at the start, but after having stripped the wheel, things like those axle bolts, you're going to struggle to get them undone with anything less than a proper ratchet or a sort of small breaker bar. So if it's probably good practice to do the same and come up with a toolkit that you can carry with you if you're going to do really long rides. So hopefully this is the final time of the top lid coming off, and we can actually connect the batteries. Or did we connect the batteries? No, we connected the batteries already. I'm not even sure what I'm doing now. Maybe I'm just checking it. No idea. Answers in the comments below. What the hell am I doing now? Oh, I'm pointing at things. Oh, okay. I'm siliconing the hall sensor plug back in again. Oh, yeah, there we go. Silicon going everywhere. Told you I was messy with it. Yeah, there's nothing more satisfying than spending loads of time doing a job like this, taking your time, being really thorough, being really methodical, and getting to the end of it and realising you've got to do it a second time. Yeah, very enjoyable. Not. So hopefully that is it. Lid back on. So the lights are plugged in, ready to go. So I've just got those 4 screws to get the top lid back in place. Just a little bit of pressure onto that lid. I found it just helps line up the screw holes properly. So yeah, I really do hope this has been, some use to someone. It's been use to me, not necessarily the video of it, but just going through it, going through the action of stripping this wheel down and rebuilding. because there's no fear anymore. Although I've stripped loads of wheels down in the past, until you've done a new wheel, that it's an unknown. What are you going to find when you take the lid off? You know, are there going to be bits that confuse you? Are there going to be bits that are a real challenge to do? And having gone through it, it's, you know, it won't faze me again to do a full strip down. You know, even right down to the motor and the hall sensors. Replacing the hall sensor was a bit of a pain. It's the fact that I'd done it before was a real help, because, you know, the hall sensors on this are pretty much the same as the hall sensors on all other wheels. They're just a small circuit board, and the components directly soldered onto them and placed in. But I did have to sort of break out the old hall sensor. I think it was glued in place. Yeah, so it was quite a lot of work to get that changed. So those little tiny rods, they're going back into the holes, get the handle back in, and then 4 screws just to get that trolley handle back in place. Again, these are going into plastic, so don't over tighten them, because you'll really easily strip the thread on those. So they're just nipped up, and sort of these sort of screws screwing into plastic, the plastic almost acts as a thread lock on its own. So, you know, they're very unlikely to vibrate loose. It tends to be only machine screws that will do that. So metal to metal will vibrate, but metal to plastic is quite solid. Last screw going in, and then I think we do a test on it just to finish off. Not the best fitting, that trolley handle, but it does work, it does the job. It's a little bit more flexible than I'd like, but it's functional. So, back on its wheel. Will it turn on? Yes, it will, and it balances. Quick check of the light. Yep, headlights working. Flashy, flashy, all good. Rear light. Yeah, all working. Good to go for a test ride. I always make a habit of riding quite slowly after a rebuild, and then build it up slowly so that I trust the wheel again. But yeah, that was my strip down and rebuild video of the veteran Sherman Max. Hope it was of some use to someone out there on the internet. Yeah, thanks very much for watching any of it at all. Bye.